Welcome to the Bare Metal Cyber Security Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. In this episode, we will explore the technical implications of change management. These are the behind-the-scenes challenges that often come with applying changes to complex systems. While approvals and planning are important, the actual implementation relies on understanding how allow lists, deny lists, downtime, restarts, and legacy systems affect operations. A successful change depends on handling these elements with precision and awareness. Let's begin with allow lists and deny lists. These tools define what is permitted and what is blocked within a system. An allow list explicitly identifies approved items, such as trusted email addresses, applications, or IP addresses. A deny list, on the other hand, identifies what is forbidden. These lists are used in firewalls, antivirus programs, email filters, and even access control systems. Implementing allow and deny lists effectively means maintaining them carefully. For example, in an email system, adding a domain to the allow list ensures that messages from that source are delivered. But if an attacker spoofs that domain, the allow list could be exploited. Similarly, a deny list that is too aggressive might block legitimate traffic, frustrating users and disrupting business operations. Improper configuration is one of the biggest risks with these lists. A misplaced rule in a firewall allow list could accidentally expose a sensitive port to the public, or a deny list could block access to a cloud service the organization depends on. These mistakes happen when lists are too broad, outdated, or untested. The key to managing them well is precision. Adding and removing entries carefully, testing changes in a controlled environment, and documenting every adjustment. Practical scenarios show how allow and deny lists can make or break a deployment. In one case, a company launched a new application but forgot to update the firewall allow list. As a result, users could not reach the service until someone traced the issue back to the firewall. In another case, a misconfigured deny list blocked a popular file-sharing service during a product rollout, delaying project timelines. These examples underscore the importance of testing list changes thoroughly before pushing them live. Next, let's talk about managing downtime and service restarts. Almost every change to a system comes with the potential for downtime. Whether it's a few seconds or several hours, unplanned service interruptions can disrupt users, harm customer trust, and even violate service-level agreements. That is why minimizing downtime is a top priority during implementation. One strategy is to use rolling updates. This involves updating systems in phases so that some parts of the system stay online while others are being changed. Another approach is using high-availability configurations, where backup systems take over while the primary systems are updated. These methods reduce the amount of time that users are affected. Safely restarting services and applications also requires planning. Some systems need to be stopped in a specific order to avoid errors. Others must restart only after all dependencies are fully restored. Restarting a database server before the file system is ready, for example, could lead to data corruption or crashes. A restart plan should include pre-checks, logging, and post-checks to confirm that everything is functioning correctly. Legacy applications add even more complexity. Many older systems were not built with today's expectations for flexibility, logging, or failover. Restarting them can cause problems if they rely on outdated libraries, unsupported hardware, or undocumented dependencies. In some cases, restarting a legacy application may require manual processes that are not well understood by current staff. That brings us to the third area, managing legacy applications and dependencies. These are older systems that are still in use because they perform essential functions or because the cost of replacement is too high. While they may work well in their current environment, they can become unstable when changes are introduced. When dealing with legacy systems, it is important to perform a thorough dependency analysis. This means identifying what the application relies on, such as databases, network configurations, authentication systems, or specific hardware. If one of those dependencies is changed or removed, the legacy system may fail, even if it was not directly touched. Documenting dependencies is key to reducing surprises during implementation. Teams should record which services are connected, what order they should start in, and what conditions could cause issues. This documentation should be updated regularly and included in change planning discussions. Real-world examples illustrate the point. In one case, an organization updated its identity provider system, only to find that an old human resources application stopped working. It turned out that the application used an outdated authentication protocol that was no longer supported. Because the dependency had not been documented, the team had to scramble to restore access. In another case, a government agency successfully moved a legacy system to a virtualized environment by carefully cataloging every dependency and testing each one in a staged rollout. The move was slow but successful, with zero downtime. As you prepare for the Security Plus exam, focus on how technical implications affect the success of change management. Know the difference between allow lists and deny lists, and be able to identify risks that come with improper configuration. Understand the importance of minimizing downtime, planning service restarts, and recognizing the unique challenges that come with legacy systems. You may see exam questions that test your ability to apply these concepts in a scenario, often involving troubleshooting a failed change or preventing an issue before it happens. Thanks for joining us for this episode of the Bare Metal Cyber Security Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.